How are you, my friends? This is Basic Math Terms, Part 24 about vectors. These terms are coming from lectures 27 and 28 of the pre-calculus course. Please, you can check the other parts in this playlist, Basic Math Terms. The terms for Algebra Course, it was from Part 1 to 18, just to remind you. Now here we have vector, equivalent, scalar, position vector, initial point, terminal point, component form, corner brackets, magnitude, direction angle, horizontal and vertical components, unit vector, dot product, perpendicular, and orthogonal. There are 16 words here we need to explain. Can start directly by saying, what is a vector? Simply, vector is a directed line segment. We have seen line segment before. So this is with a direction. See, this is a direction. It can go in any direction. Two vectors are equal or equivalent if they have the same magnitude and the same direction angle. Magnitude is like the length, but we call it in the vectors magnitude. And the same direction angle. Here there are three examples. The first, U and V are equal, E and F not equal, C and D are not equal because they have opposite direction. Scalar, the word scalar, multiplication, we can multiply a vector by a scalar. It can be positive number, negative number, fraction. See, if you multiply U here, if U is a vector, 2U is another vector with magnitude 2 times the magnitude of the U. This is half U, same direction, but smaller. This is minus 3U, opposite direction, multiplied by 3. Vectors in the coordinate plane. Vectors are written in this way by using corner brackets. So we write here corner bracket AB, that means the vector U, this blue one here. So there is a starting point here, the initial point. If the initial point at the origin, and then there is another point here, maybe this is like say A to B, okay? So we say the vector is a position vector. If the initial point is not at the origin, just call it a vector. Geometrically, a vector is a directed line segment, as we mentioned in the first slide. So this is the blue one with the direction and the magnitude. Algebraically, we can write it as an ordered pair, AB. See, when you write AB, that means a vector, but you have to write corner brackets, not only brackets like this as a point. Direction angle is the smallest positive angle in standard position formed by the positive x-axis and the vector itself. See this one here, the theta. This green here, this is the theta. We call this direction angle. It can be from 0 to 2 pi. Component form. See, this is an example where we have the initial point is not on the origin. So we have a vector starting from P to Q. It can be in any place. So we call the initial point P, x1, y1. These are the coordinates of the point P. Terminal point is Q, x2, y2. So we can write the vector PQ starting from P to Q as x2 minus x1, that's the first component, y2 minus y1. So this is the component form of a vector in general. The magnitude, if you have a vector like this, position vector, see in the corner brackets here, we write AB. To find the magnitude, which means the length, but we use the word magnitude, we put here 2 bars, but we don't say absolute value. We say the magnitude of U is equal square root of A squared plus B squared by using Pythagorean theorem for this right triangle. This is 90 degrees here. Now the direction angle, you can take tan theta b over a. We have a and we have b. We divide b over a, then we can find the direction angle theta. Horizontal and vertical components. If we have the same vector u, and this is the magnitude of u, direction angle is theta, then we can write also cosine of theta here is equal to a, cosine of theta a divided by magnitude of u, because this is the adjacent over hypotenuse. So when you cross multiply, you get a, the magnitude of u cosine theta. That's the a here, you see? So we call this horizontal component. Only this a, we call it horizontal component. It will go here, the first. So this one will be the horizontal component. Now, if you take sine of theta, will be the opposite, b divided by the magnitude of u, cross multiply, you get b is equal to magnitude of u times sine of theta. See, this is the b here. So we call this vertical component. So they can ask you to find the horizontal or vertical, or you add them, you multiply them, whatever. So if you have a vector AB, directly you can write the magnitude of u cosine of theta. First, this is A. B will be the magnitude of u sine of theta. This is very important rule here. The dot product, if you have two vectors, u and v, AB is the u, CD is the v. To find u dot v, we write it like this. We don't say multiply, we say u dot v. This is the dot product. It will be AC, you multiply the first component with the first component, you add second component with the second component, you multiply them. This is an easy, nice example. If you have a vector u, 6 minus 2, that's AB. If you have a vector v, minus 5, 3, this is CD. To find u dot v, 6 times minus 5 plus minus 2 times 3, it will be minus 36. There is another formula, we call it dot product theorem. This is u dot v, the magnitude of the u times the magnitude of the v times cosine alpha. This is not theta, guys, here. Alpha. Alpha, it means the smallest non-negative angle between the vectors. So this alpha here will be between 0 and 180. This is one time. I wrote it another time here. Alpha between 0 and 180. This is the angle between the vectors. You can call it theta if you like, but you have to know what is the meaning. Is it the angle between two vectors or only the direction angle of a certain vector? So this alpha here is between. You see the word between here. Now from this one, you can divide, this is a number, magnitude of u, magnitude of v. You can divide by these two numbers. You will get cosine of alpha, u dot v divided by the magnitude of u times the magnitude of the v. Now you can find alpha as cosine inverse of this is a number here, whatever this number. Can be simple or not simple number. Let's look at this nice example on vectors. Find the smallest positive angle between the vectors. If we have a vector E and a vector F. E is 2 minus 6, F is 6, 2. Let's find the smallest positive angle. So this is E and F. Okay, we need cosine of alpha. Cosine of alpha will be u dot v. So 2 times 6, and then you add minus 6 times 2, divided by the magnitude of the u. See, this is the formula here. That's the formula, u and v. And in our question, we have E and F. Be careful there. Find the magnitude of E, and this is the magnitude of the F, which is the magnitude of U and magnitude of V. So you get 12 minus 12, that's 0 divided by 40, which is 0. So let's find alpha now. Cosine inverse of 0. What is the angle whose cosine is 0? That's pi over 2, 90. See, just imagine two vectors, the angle between them is 90. So we can conclude that the vectors are perpendicular. Now, one important word we use for perpendicular in the vectors, we call them orthogonal. So orthogonal vectors when the dot product is equal to 0. Because here, the main idea here, 12 minus 12, that's 0 divided by any number. Non-zero will be, the answer will be 0. 0 over 40, 0 over 7, 0 over 1, 0 over 100, 0 over 16, it will be 0. So if the dot product, that's the rule now, if the dot product is equal to 0, then the vectors are orthogonal or perpendicular. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you guys for listening.